what we're going to look at here is slope-intercept form. So slope-intercept form can be written as y equals mx plus b. Now this is called like a generic form of the equation. So in this form, x and y represent an ordered pair in the relation. Okay, so x and y can change depending on what x you decide to use as your input. So remember, at the very beginning of this, we said x is the input and y is the output. Whoops. Okay, m is the slope and b is the y-intercept. And it's going to be represented with the point where x is 0, y is going to be b. Okay? So let's look at a specific example. So if I say y equals 3x plus 4, 3 is m, which is the slope. 4 is b, which is the y-intercept. X and y then represent different inputs and outputs. So if I said x is 0, y would be 4. If x is 1, y would be 7, and so on. So let's take a look at how this works. So what I did is I put in 3 different equations, and the only thing I did is I changed the number in front of x. So it's 1x, 2x, and 3x. And if I graph this, you'll see the only difference between the 3 lines is the slope. So this has a slope of 1, this has a slope of 2, and this has a slope of 3. So a bigger slope means a steeper line. So again, the only change I made was to the number in front of x. Now, let's say I make this negative 1x. What you're going to see is, whoops, I see what I did wrong. I need to make negative 1x, okay. The difference is, instead of going up from left to right, it goes down from left to right. So changing the number in front of x changes the slope of the line. Now, if I change this number, which is b, but leave the slope the same, and we can do one more, x plus 4, what you'll notice is that the lines are parallel because the slope, they're just as steep, but where the line hits the y-axis changes. So in this case, it was x plus 1, so you have a y-intercept at 1, at y equals 1. This is x plus 2, so the y-intercept is at y equals 2, y equals 3, and y equals 4. So that's exactly what these equations are telling us. So if we go back to y-intercept form, m, the number in front of x, tells us the slope, and b, the number after x, tells us where does that graph hit the y-axis. So if we're going to graph a line and we're given an equation in slope-intercept form, I have all the information I need in order to make this graph. So here, I know that the line is going to hit the y-axis at negative 3. So I can put a point there at 0, negative 3. And I know that this is my slope, and I know the slope, that 4 over 3 is my slope. And the slope represents the change in y over the change in x. So the change in y over the change in x. So then I know I have to move up 1, 2, 3, 4, and over 3. That's it. We'll do one more. Here I know that my line is going to hit the y-axis at y equals -2. So at the point 0, -2. And I know that my slope is 1 because there's an imaginary 1 in front of that x. So that means I'm going to move up 1 and over 1. 2 points is all you need to graph a line. Let's do the one with a negative slope. So I know that my graph here is going to hit at y equals +3. So I'll put a point there at 0, 3. And what this means is that I'm going to go down 1 and over 3. This negative tells me I'm going to move down 1. Okay, down 1, over 3. That's it. Now sometimes you're going to be given that you have an equation for a line, and you're given the slope, and you're given the point of the y-intercept. The slope is m, and this point here is b. You can ignore the 0. The 0 represents the x value for this particular point. Okay? So y equals mx plus b. In this case, they tell us m is -6, so y equals -6x plus 3. Let's try the next one. So we have a slope of 4/3, so y equals, that's m, 4/3 x, and then this number here is b. The y-intercept is 0, -2, so -2. When you get something like this, I think I put the letter O here. I should have put a 0. Oh, maybe I did. Yeah, that's what 0 looks like. Okay, whatever. All right. So if they just say a y-intercept of 0, or sometimes they'll say a y-intercept of 4, what that means is that the point 0, 0, or 0, 4 in this case is the y-intercept. So here you would have y equals -2/5 x plus 4. Here you would just have y equals 1x, so we can just write that as x, plus 0. So I can just say y equals x. This is in slope-intercept form. Sometimes you're going to be given a line and told, write this in slope-intercept form. Now I know that your copies were a little bit smudgy for the hard copies, but it's a little bit easier to see here. So what I need to know is what is the slope and what is the y-intercept. Y-intercept is always really easy to identify. Where does the graph cross the y-axis at what y value? So y equals 3. Now the slope, what I like to do is find a point at which the graph clearly crosses through the grid, so you can get a nice whole number. I know that my slope is going to be negative because it's moving downward from left to right. And so I have to go down 1, 2, 3, 4, 5. And to the right, 1, 2, 3, 4. So my slope is -5/4. And my y-interceptor b is 3. Another thing you can do if you want to calculate the slope is I know that this point is 0, 3. And this point is 4, -2. And so you can use the slope formula, y2 minus y1 over x2 minus x1, and you end up getting negative 5 over 4, just like we counted. But now I'm told write the equation in slope-intercept form, so I'm going to write y equals negative 5/4 x plus 3. We can do this one too. So again, it's really easy. Whoops. It's really easy to see where the graph hits the y-axis. So right here, it's at y is negative 5. So b is negative 5. The slope is going to be positive, so I'm not going to put a negative number in. And I'm just going to find a spot where it hits the grid really nicely, and that looks like right here. So here my point is 0, negative 5. Here it looks like I'm at 5, negative 4. So you can count up 1. And then I go over 1, 2, 3, 4, 5. And you can also do y2 minus y1 over x2 minus x1, and you should get 1 over 5. And then I just plug it in. Y equals 1/5 x minus 5. So that's slope-intercept form. So anytime you're given the slope and a y-intercept, you can write it in slope-intercept form. And then, where were we? If you need to graph, you know that this is your point where the graph is going to hit the y-axis, and this is how many up and over you're going to be moving, or down and over. All right, that's it.